Okay, the constant multiplication rule. If c is a constant and f is a differentiable function, then the derivative of c times some f of x is going to equal to you can factor out that c. Is that what it's trying to get here? You can factor out c. So it would be c times d dx of f of x. Kind of like the limit rule of factoring out a constant from a limit. Is the same thing as with the derivative here. So let's see, how can we apply this? Okay. Differentiate each of these functions. F of x is equal to 3x to the fourth. I guess we could follow the rule here of what it says, that this would be what, factor out the 3 and then take the derivative, d dx of x to the fourth. But you're not going to be doing all this. We'll do it faster. And then the derivative of x to the fourth, by doing the power rule, then you get what, 3 times, and the derivative of this is going to be, what's the derivative of this in the inside here in the brackets? 4x cubed. And then you can multiply this 3 times 4 here is 12x cubed. That's too much. You got a constant in the front right here. You just multiply that constant with that 4. So in reality, you shouldn't be taking that long. It's just 4 times 3. 4 times 3 is 12. X to the third. So there's an invisible number here in between negative here. There's a 1. So what's the answer to this then? So what would be the derivative? Oh, well, the derivative would be that. No, not that, but the derivative. F prime of x should be what? F prime of x should be 12x to the third. And the derivative of this one should be what? F prime of x should be what here? Anybody, come on. What's the derivative of this? I said multiply this 8 times the negative 1. You're multiplying. So what is 8 times negative 1 will be negative 8x to the what? Yep. So you're multiplying times that, whatever that number in the front here is. All right. Okay, let's go ahead and do a problem now. Let f of x, that could be on the AP, these kind of problems, or you could be tested on. Let f of x be this 8th degree polynomial. Find the derivative. Don, you wanted to try to come up and do this one? Come on, man, let's go. Oh, what's the other person there? You wanna, is Rufus. You wanna come do this one? No, nobody. Anybody wanna come up and do it? Come on, somebody. America, you gonna come and do it? Vivian. Come on, what the heck is wrong with this class? Sean, you gonna do it? No. Anthony? What the? You serious? F prime of x. F prime of x is going to be in front of x is a 1. You multiply 8 times 1 is 8. Subtract 1 from 8, 7. You're going to multiply 5 times 12. 5 times 12 is what? 60. 60. Subtract 1 from 5 is x to the 4th. Multiply 4 times negative 4. 4 times negative 4 is negative 16. X to the what? X to the 3rd. Where am I at? I'm with this one. And then 3 times 10. What's 3 times 10? 30. 30 what? X what? Squared? And then what? Minus, then, isn't that minus 6? That's the negative 6, because that's just going to go to nothing. The x is going to just go away. And then the derivative of a constant is 0. So that is the derivative right there. Problem number 2. Find the derivative of that. All right, so this looks kind of weird, and so how can we apply that this derivative rule of today to this? You would have to like do some what, algebra again. It just goes back to so much algebra here. Why don't you just kind of put it where it's going to be before you take the derivative? Let's divide this by this. What would that be? That would be 3 over x squared. And then divide this. That would be what? 7 over x to the 3rd. And then move this to the top and move this to the top. So y would be 3x to the negative 2 plus 7x to the negative 3. And now you can go ahead and do the rule of today. Y prime is going to equal 2. Negative 2 times 3. Negative 2 times 3 is negative 6. X to the what? Negative 3. And then negative 3 times 7. Negative 3 times 7 is negative 21. X to the negative 4. And then just kind of simplify it. Yeah, I was with those Facebook friends, my math friends. I don't know if they're my friends, but whatever. They're in AP friends. They're saying, would this be acceptable? Is this okay? That is, but on a multiple choice, rarely do they leave it as negative exponents. So more than likely, the answer will be this: negative 6 over x to the 4, x to the third. Move it to the bottom. Make it a positive exponent. So x to the 4th. Let's see. Yeah, more than likely. But then again, it's just kind of like you got to be able to recognize that these both are equivalent. Let's see. What do I have here? Yep. Okay, let's go ahead. Let's do number 3. Kind of the same procedure I did here. So more than half of the steps are algebra, and the rest is the calculus part. So let's get it ready. F of x, we haven't taken the derivative. It's just f of x. F of x is going to equal 2 again. F of x is going to equal 2. Go divide this. Can we divide this? That'll be what? Anybody? 3x cubed. Then we do this. What is it? Minus 2x. And then this. Okay, that one's a little more weird here again. Negative 3x to the 1/2, because square root of x is 1/2. And then you got over x. And then you subtract here. Yeah, so then this is going to be minus 3. Then you got 1/2 minus 1, which is 1/2 minus 2 over 2, which is negative 1/2. So this is going to be x to the negative 1/2. And now we can take the derivative of this. And f prime of x is going to equal 2. What is it? What is the derivative? What's the first part? Anybody? 9x squared. Then next is going to be what? Minus 2. And then multiply. We're multiplying, you know? So a negative times a negative is a positive 3/2. Positive 3/2. And then we're subtracting 2 over 2, which is going to be negative 3 over 2. So it's going to go to the bottom. This is x to the negative 3 over 2, which is going to be x to the 3/2 at the bottom. Again, be able to recognize this. You see how I got 9x squared, that matches up, minus 2. And then I got this other thing, they put it back to radical form. But they're both kind of equivalent answers. So if it's on a multiple choice, you got to be able to quickly see be able to change it from fractional exponent or to radical. All right, let's go. Number 4 next. Continue. Number 4, if f is the function given by this, then what is the derivative add to? So again, take the derivative and evaluate it at 2. What's the derivative of the first part? What's the derivative of this? So you got to be able to quickly kind of move it around. You know that the x got to go to the top, so it's going to become 4x to the negative 1. I'm just doing it here on the side. Then you got to move that, multiply negative 1 times 4. Negative 1 times 4 is negative 4. And then you're subtracting 1 from it, so it'll be negative 2, x to the negative 2, which now has to go to the bottom, so it's going to be negative 4 over x squared, no? Yes? Yes. All right. So after a while, I guess sometimes like it becomes repetitive, and then you get used to doing it like fast. All right. Let's continue. The next one is going to be 5, and then the constant goes away. Now we can evaluate at 2. Negative 4 over 2 squared plus 5. And that's 4. It's going to be 4. Continue number 5. Let's continue on number 5. Find the points on the graph of this 4th degree polynomial where the tangent line is horizontal. So a little background knowledge on 4 degrees. This is pre-calc. 4 degrees look like what? X to the 4th. They look kind of like what? You have to look. Let me give you a little background knowledge for this. So what does f of x equal to x look like? That's linear, no? So this is going to be some kind of line here, no? So that has when would it be horizontal? For this one, it's only when it's exactly horizontal, the line, no? For a quadratic, it would only have one time where it would have a horizontal tangent line, no matter what, no? It would be one time. It would be here, no matter what. If it's upside down, it'll be right there. A 3rd degree looks like a sideways S. Just flip, so it'll be like this. and then it would have two possible points where it would have a horizontal tangent line. And so a fourth degree, if it does, then it would turn it back up. It looks like a W. If it does at the most, then it would have three possible points where you would have a horizontal tangent line. 1, 2, 3. So at the most, it would have three. Maybe just one, maybe two. But not more than that. No, let's see. Let's go. So you're looking for, let's see. So what are we gonna do? We've got to take the derivative. So we'll find where the slope is equal to 0. So when it says find the points of the graph where the tangent line is horizontal, take the derivative, set it equal to 0. That's the key here. Whenever you see one of these problems, take that derivative and set it equal to 0, because that's when the slope is 0. So we're going to take the derivative, set equal to 0. So f prime of x is equal to what? Let's go. Help me out. What's f prime of x? 4x cubed, then what? Minus 12x, then what? That's it, huh? Because the 4 goes away, no? And we're going to set it equal to 0. And we want to know for what x values is it equal to 0. Now, this was calculus. This is the calculus part. This is calculus. What we're going to do now is algebra. Just algebra. This thing here is algebra. Factoring. See, it comes back to factoring. Couldn't I factor out 4x? Yes, that's greatest common factor, 4x. Let's do that. And then what's left inside then? Come on, somebody. X squared, and then what else? Minus 3. So then we use the zero product property and say 4x equal to 0. And then x squared minus 3 equal to 0. And solve. So 4 times 0 is 0, so this x is 0. So at x equal to 0, and then you add 3 here. So it'd be x squared equal to 3. And then square root it. Square root this, and you're going to get x equals plus or minus square root of 3. So it does have 3 at 3 points, at 3 spots. At 0, at negative root 3, and at positive root 3. If you want to see what it looks like and what I'm telling you, that the quadratic looks like a exact W almost. So here's the answer. So here it is. And if you want to look at the graph, oh, I took it out. Oh no, I used to have it. All right, so let's go number 6. Let's move on, I guess. Number 6. Find the equation of the tangent line and normal lines of the following function at the given value of x. See, here's where again, I was yesterday or whenever it was that they're talking about how the AP exam is kind of more difficult than taking it at a community college or something like that. They're like, because in the AP you have to really understand the question and apply the math involved with it. So in this particular problem, number 6, it says to find the equation of the tangent line and the normal lines of the following function at the given value of x. Let's do the first part first. Find the equation of the tangent line. Well, that one, we've been doing this for a while now. Isn't that the one where we go like this? Remember, we're going y minus, and that's the one. You got to be able to know which one it is. So this would be that you need to find the slope at that point. So it's going to be what? For that first part, find the equation of tangent line. So what do I plug in for after x minus? What do I plug in here? 3. And then what do I put here for the y? Let's see. Let's kind of, that's going to be, let's do that kind of quickly. Let's do this. That'll be what? 3 cubed minus 4x is 3 squared plus 3 plus 3. 3 cubed is 27. 3 squared is 9. 9 minus 36 plus 6. 3 is 6. So 23 is negative 3. So it's going to be 27 plus 6. 33 minus 36 is minus 3. So this is negative 3. So you just got to evaluate it at this, in this function. No? And now we take the derivative and find the rate of change for it. Now this is the calculus. No? Take the derivative to find this part. F prime of x. So what's the derivative? Help me out again. Anybody? What's the first part? 3x squared. And then what else? Minus 8x. And then what else? Plus 1. See, in this one, we don't set it equal to 0. None of that. It's just we want to know what is the rate of change at 3. So we're going to go f prime at 3. What's the derivative at 3? What's the rate of change at 3? And we're going to plug it in. So what's this? 3 squared is 9, 27 minus 24 plus 1. So that's going to be what? Where is that? Is it 4? Is it 4? 4? Okay, so we're done for this part. What is a normal line? Does anybody remember what a normal line is? Look. Normal lines, whenever they say normal lines, is that they're perpendicular to each other. Okay? So if this slope goes, if something goes like this, the normal line to this would be like this. So how do I find the slope of the normal line? All you gotta do is this. The slope of a normal line would be the slope of this line is 4, no? The slope of this line is 4, m equals 4. The normal line to a line that has a slope of 4, and we go like this, that is perpendicular to it. All you gotta do is flip it. So what's the reciprocal of 4? Reciprocal, what you guys said? What's the reciprocal of 4? 1 over 4? And then also do the opposite sign. So then it's going to be what? Negative 1/4. That's it. So the slope for the normal line, it will be, everything is the same. So for the normal line here, everything is the same except that this slope. So for the normal line, it will be y plus, because it's plus, y plus 3. And then the slope will be negative 1/4, and everything is the same because at that same point. So that's for the normal line. And for this, for the tangent line, it would be this. So this would be a tangent line, and that's the normal line. So yeah, it's just the reciprocal and opposite. Reciprocal and opposite. All right, next. Here we go, number 7. We might finish with this one today here. What values of a and b would make the function differentiable at x equal to 3? And we did this problem, a problem like this, for the homework last time, the one on Friday actually, the one that I had already done the trick, and it wasn't supposed to be done that way because we're supposed to do it a different way, which is way more work, the other way. This is so much easier. Well, I don't know, it depends on what you consider easy, but, so what values of a and b would make the function differentiable? I don't know if you guys watched that video of that one lady teaching it on AP Classroom, where it goes like this. You have to really understand continuity, and differentiability. Differentiable. Continuous and differentiable. Something can be continuous, but not differentiable. So this right here is continuous from here to here, from A to B, whatever, no? From A to B, it is continuous because I'm not lifting my pencil. It's continuous. But it is not differentiable because of this, because of the corner here. So something can be continuous and not be differentiable. But continuity is the most powerful. No, differentiability is the most powerful, because if it is differentiable, if it says that something is differentiable from A to B, is because it is differentiable everywhere. It's smooth. And so automatically, if it's differentiable, it must be continuous. So this, if it's differentiable, it must be continuous as well, where it doesn't go the other way. Sometimes it is continuous and differentiable, but not all the time. So differentiability is the most powerful here. Okay, so now, what values of a and b would make the function differentiable at x equal to 3? I'm going to assume then that it is differentiable. And since it is differentiable, it must be continuous. And if I believe that, then I can do this problem. So assume continuity. Continuous. Assume that it is continuous. Continuous. Because I'm assuming that it is continuous, because I want it to be continuous so that I can solve for a and b, then I can just plug it in. Just plug in x is equal to 3 for the left-sided limit, and I plug in x equal to 3 for the right-sided limit. Let's do it. So x is 3 squared minus ax is 3 plus 2 has to equal to x is 3 plus b. That's the first thing you got to assume that it is true. And you have to assume that it's also differentiable. And if it is differentiable, then we can take the derivative coming from the left and from the right. So let's take the derivative coming from the left. Okay, so f prime of x from the left has to equal to, from the left, this is from the left, has to equal to coming from the right. They have to equal each other. So let's take the derivative of this coming from the left. What's the derivative of this? Let's go. That's what was the lesson for today. What's the derivative of x squared? What's the derivative of x squared? Isn't it 2x? And a is just some constant. That's what it's saying, some number. So then the derivative of this will be what? Minus a. And the derivative of 2 is nothing, 0. Or then the derivative of this is what? Coming from the right, it's going to be what? 1. And also, I should also just plug in. Well, that's what I'm doing right now. I'm going to plug in 3 for x. So let's plug in 3 for x. 2x is 3. And now I can solve for a. This is so much easier than the other one. So 2 times 3 is 6. 6 minus a is equal to 1. Move it over and move it over. So a is 5. But now I know what a is 5. If I know a is 5, then I can just plug it in here and solve for b. Easy. 9. 3 squared is 9. Minus 3, where a is 5. I'm going to plug in a is 5. 3 times 5 is 15. Minus 15 plus 2 equals 3 plus b. And now I can solve for b. 9 minus 15, negative 6 plus 2 is negative 4. Negative 4 equals 3 plus b minus 3. So b is negative 7. So if this is differentiable at x equal to 3, then a has to be 5 and b has to be negative 7. Unless I did something wrong. A equals 5, b is negative 7. Yeah, let's finish with number 8. Let's go. Let's do this number 8. Last one. That's enough. So on the AP exam, going back talking about AP exam, that they just like they put them all together and they can go in from chapter 5 to chapter 1 and mess you up. It says evaluate this limit. And they're like, I have no idea what to do here. What the heck is this? Evaluate this limit. But if you understand the definition of the limit, it's going back to the definition of the limit. There were 2 definitions, and this one looks to be this one second definition of the limit. The second definition of the limit says something like the limit as x approaches a of what? F of x minus f of a over x minus a. So this, they're looking at this definition. Limit x approaches, yep. So a equals 1. You see, limit as x approaches a, limit as x approaches 1. 1 is a. So I know that a is equal to 1. For sure, a equal to 1. Oh, so easy. Oh my goodness, this is so easy. What is f of x? And now I'm gonna just kind of like use the new tricks. Isn't f of x gonna be this? So now I can just take the derivative of this and then evaluate at this. Yep. So f of x is going to equal to 4x to the third plus 3 square root of x. Take the derivative and then evaluate at this point. So I'm just kind of cheating here. So f prime of x, is going to equal to, what's the derivative of this? What's the derivative of this? Somebody please. 12x squared. And that is going to be what? 3 to the x to the negative 1/2. Because you move this to the top. The negative 3/2. Negative 3/2. And then you're gonna minus 3 halves, minus 2 halves, no, minus 2 over 2, which is minus 3 halves. And negative 3 halves, put it to x to the 3 halves. And now we can evaluate. Just evaluate now at 1. So f prime at 1. F prime at 1 is going to be equal to 12, 1 squared minus 3 halves. X is 1, 1 to the 3 halves. So 1 squared is 1, 1 times 12 is 12, 12. And then this is going to be 1 to whatever 3 halves, whatever that is still 1. And it'll be minus 3 halves. So 12 minus 1 and a half. What's 12 minus 1 and a half? 12 minus 1.5. Is that 10.5? 10.5, and sometimes they leave it as improper. 10. So this is going to be 10 and 10 to the 1 half. And so it'll be what? 22, 23 over 2? 23 over 2. And that's how they probably have it on the AP. They wouldn't have a decimal. They don't like decimals. They leave it as fraction. Oh no, I messed up. Did I put 23 over 2? Yeah, oh, you know what? I am right. Hold on. 10 times, no. 10 times 2 is 20. 20 plus 1 is 21 over 2. So, I don't know how to do simple math sometimes. So, it is 21 over 2, not 23 over. That's enough. That's enough for today. Let's stop.